the differential volume that I want to then integrate, the differential volume is going to be like the length, which is 2 twice pi, or 2 times, or 2 times pi, the radius, and then the radius is this distance, and then the thickness is differential x. Is this? Can I get an equation for an x? The only relationship I can see between r and x is the tangent, and I don't like the tangent because of the integral. It's going to be good. 2 pi r dx. I have to relate r and x because I don't need two variables. I only need one. R, but the d. How about the d? Changing it. Okay, let's take the trigonometry. X is d cosine of theta. R is d sine of theta. So tangent of theta is r divided by x. Not a very good idea. No. Differential of x with theta. Okay, x would be r divided by tangent of theta. So it's getting more and more complicated. If I do the differential of r, I will have a inverse tangent. I have no idea. I'm suffering because I don't have any. I don't know how to solve. I don't remember my integral calculus. My mechanics gonna help me. Let me think. I have to see one differential and then I have to sum all of them. 2 pi r differential of x. I need the relationship. The relationship is not clear with a tangent. I can try to write it, but anyway. The volume is going to be the integral of all the differential volumes. It's going to be 2 pi r. How about differential of x? Differential of x is going to be the tangent. The tangent is going to change, and the r too. So I have, instead of one, I have two variables. There's no way to solve it. Differential of x would be, I don't know how to do differential of x. Differential of x, to be honest, should be partial of x with respect to r, differential of r plus partial of x with respect to theta. It's a variable, right? Yeah, or with respect to tangent. I hate that. I think it's through tangent of theta. Differential of tangent of theta. That's becoming more and more, you know. I remember this failing during the exams. The worst of all is not facing a problem. The worst of all is the feeling that you should have studied more. That's the worst thing. I have no idea how to do it. And then one of the students said, oh, I don't know how to solve it. I'm such a bad student. I want to be such a bad physicist. Is there another way to do it? Is there rings? What if I do it vertical? Maybe, I don't know, it seems stupid, but if it's vertical, is there anything that changes? Nothing. Nothing really. It seems easier, right? The radius. A ring is 2 pi r, and the thickness. So something. Okay, if I plot a square like this, if I plot the ring vertical vision, the radius will be here, right? Yeah, how about the thickness? Should I consider differential of x? I don't know. I don't know. Is this differential of x? Yeah, but if I could solve this problem, this small problem, that would be differential of r. Right? Doing a like a larger view, that will be differential of r. And that will be differential of x. How are they related? Is they using Thales? This angle is the same. Yeah. Yeah. That could mean that differential of x is r cosine of theta. That will solve all the problems, all my problems. Okay? So the idea is that instead of working with a ring and I don't see anything, walking in another plane, so have a cut, so the ring is like a ring like this, okay? Ring is like this, yes, but the radius goes over there, the radius, you see? And the thickness is horizontal, the differential of radius forms an angle, exactly the same angle. So I think this intuition is, yes, I felt it before, but I have forgotten how to rethink it again. So that could work. That could work because, why did I write it? I don't know. There. Differential of x is r cosine of theta. Differential of r. So differential of r cosine of theta. Yeah. That will be the thickness of the ring. Ring thickness. Now I need the what? What do I need? I need the radius. The radius. So the differential volume is going to be 2 pi r, okay, times dx. How about that? Makes sense, but the cosine, I don't know how to go to do it. The angle is going to change from 0. What if I do only half? And then the other half will be double, right? From 0 to 90. So the volume is integral of differential of v. Yeah, I don't know. Yeah, okay. But in a nice way. It's going to be, yeah, but differential of x. Where is the angle? Differential of x. There. So this, yeah, is what I just put. 2 pi r differential of x. I saw that differential of x is differential of r cosine of